All right, next up we have probably what's the most common type of reaction, oxidation reduction reactions. They're also sometimes called redox reaction for reduction oxidation. Right, they're extremely common. And originally they were used to describe reactions with oxygen. Hence oxidation, oxygen, right? But later on, they found out that all kinds of reactions are actually redox reactions. All redox reactions are transfers of electrons. And this is why they're extremely common. If you think about what we do in chemistry, we don't change the identity of the element. We don't change the number of protons or neutrons. What we do is we mess with electrons. We break bonds, we form bonds, we transfer electrons, that kind of things. It's all about the electrons. So a good mnemonic for this is oil rig. So if we're transferring electrons, something has to give up electrons and something has to get electrons. So oil rig is the little way to memorize it. Oxidation is loss of electrons, and then reduction is the gain of electrons. So if your atom or molecule gains electrons, it has been reduced. If it loses electrons, it has been oxidized. Let's take a look at this. We're going to have some zinc solid plus some iron in solution with a 2+ charge, and we saw this in lab, or at least we're supposed to see it. And then zinc 2+ in solution, and then iron coming out as solid. If we think about what's going on with the zinc went from zinc to zinc 2+, which means that it lost electrons. So it is being oxidized. If we think about what happened with the iron went from a 2+ to iron 0, so it gained 2 electrons. It is being reduced. Now, here's where things get a little bit more confusing. Instead of talking about what the element is undergoing itself, we often talk about what the element is doing to something else. So instead of saying something is being oxidized or being reduced, we say that something is acting as an oxidant or reductant. So for example, a reductant or a reducing agent, instead of talking about what is going on with that atom, we're talking about what it's doing to something else. So a reductant or a reducing atom reduces something else. And so it gives up its electrons to something else, and it itself is oxidized. So for example, in our example up above, the thing that gave the electrons up was the zinc. So the zinc reduced the iron, and so the zinc is the reductant or the reducing agent. And then vice versa, the oxidant / oxidizing agent is something that oxidizes something else. So it's taking away electrons from something else, so it itself gains electrons or is reduced. So if we think about our example above, the iron took electrons away from the zinc. It oxidized the zinc, and so the iron is the oxidant or the oxidizing agent. And so it's just a little bit confusing. You really have to be careful about what the question or what the person is asking or how you're talking about it. Are you talking about what's happening to that element, or are you talking about what that element is doing to something else? Overall, redox reactions are very easy to see with metals because they have positive or negative charges, so it's very easy to tell where the electrons are going. However, that's not the only type of redox reactions that we have. So redox reactions happen all the time. It's just harder to see with nonmetals. So for example, hydrogen gas plus chlorine gas will give us some HCl gas. This is also a redox reaction. So next up, we're going to learn how to identify redox reactions with nonmetals, things that don't have the charge and where it's a little bit less obvious.